Every great empire believes it is the exception to the rule, that its strength is permanent, that its institutions are too sophisticated to fail, that the forces that destroyed previous civilizations somehow don't apply to them. And yet, with almost mathematical precision, they collapse anyway. Sumer, Egypt,
Rome,
the Maya, the Khmer, Ming China, the Ottomans, different continents, different technologies, different belief systems. But the arc, the shape of their decline, follows patterns so consistent that some researchers now argue we're not looking at coincidence. We're looking at a structural inevitability, a kind of systemic timer built into the very architecture of complex societies, one that begins counting the moment a civilization reaches its peak. And here's what makes that deeply uncomfortable. The timer runs for about 6,000 years. Let's start with something that sounds simple, but isn't. Complexity is a death sentence. Not because complex systems are weak, they're not. They're remarkably resilient, at least initially. The problem is that complexity doesn't stay static. It compounds. And every additional layer of complexity introduces new vulnerabilities that weren't there before. Take Sumer. Around 4500 BC, they invented large-scale irrigation. This was revolutionary. It allowed them to support denser populations, build cities, develop writing, create specialized labor. But irrigation requires maintenance. It requires coordination across large territories. It requires centralized authority to manage water rights and prevent upstream communities from monopolizing the supply. So they built bureaucracies. And those bureaucracies required taxes. And taxes required record-keeping. And record-keeping required a literate administrative class. And that class required compensation. And compensation required more agricultural surplus. And more surplus required more irrigation. You see the loop. Each solution creates new problems that demand more solutions, which create more problems, which demand more complexity. This is not unique to Sumer. It is the pattern of every expanding civilization. The issue is that complexity has a carrying cost. And at a certain threshold, a threshold that varies by region and resource availability, but appears to cluster around a 6,000-year lifespan for agricultural civilizations, the cost of maintaining that complexity exceeds the society's ability to generate surplus, at which point the entire structure begins to destabilize. This is what historians call the point of diminishing returns on complexity. And once you cross it, collapse isn't a possibility. It's a countdown. Let's look at what actually happens when civilizations reach this threshold. Because the sequence, when you map it across multiple societies separated by thousands of years and thousands of miles, is disturbingly consistent. Stage 1. Resource depletion. This is almost always environmental, though the specifics vary. Soil exhaustion from over-farming. Deforestation that disrupts rainfall patterns. Overextension of irrigation networks that leads to salinization. Salt buildup in the soil that renders fields infertile. The Sumerians experienced this. So did the Maya. So did the Romans in North Africa. The land stops producing at the levels the population has come to depend on. Stage 2. Economic stress. Agricultural decline means less surplus. Less surplus means less tax revenue. Less revenue means the state can't pay its soldiers, its administrators, its engineers. Infrastructure begins to decay. Roads go unrepaired. Aqueducts crack. Defensive walls crumble. Rome is the textbook example. By the 3rd century CE, the empire was spending more on maintaining its borders than it could extract from its provinces. The economic model, conquer new territory, extract wealth, fund the military, had stopped working because there was no more territory left to conquer. They tried debasing the currency. They tried raising taxes. They tried forced labor. None of it addressed the fundamental problem. The structure was too expensive to sustain. Stage 3. Social fragmentation. When the state can't deliver what it promised, security, food distribution, infrastructure, justice, people stop believing in it. Not all at once. Gradually. But once that belief erodes, the legitimacy of the entire system comes into question. Elites begin hoarding resources. Regional governors start acting independently. Trade networks break down. Cities depopulate as people move back to subsistence farming because centralized food distribution can no longer be trusted. This happened to the Khmer Empire in Cambodia. At its height in the 12th century, Angkor was one of the largest urban centers in the world, sustained by an elaborate hydraulic system. But when that system began to fail, partly due to overexploitation, partly due to climate shifts, the population scattered. Within a century, the city was abandoned. Stage 4. The trigger event. Here's the thing about civilizational collapse. It's rarely caused by a single catastrophe. Invading armies don't destroy stable, resilient societies. They destroy societies that are already fracturing from within. Droughts don't collapse civilizations that have functioning trade networks and surplus storage. They collapse civilizations that have exhausted their margins and have no buffer left. The external shock, a barbarian invasion, a plague, a volcanic eruption, a prolonged drought, doesn't create the collapse. It reveals the structural fragility that was already there. The Western Roman Empire didn't fall because of the Goths. It fell because by the time the Goths arrived, the empire had already stopped functioning as a coherent political entity. The trigger is just the moment the invisible cracks become visible. So, here's the question that haunts this entire discussion. Why does this pattern seem to repeat on a roughly 6,000-year cycle? Is that real? Or are we imposing a pattern on noise? The honest answer is, we don't fully know, but there are compelling theories. The first is agricultural. Most ancient civilizations were built on early forms of intensive farming, irrigation-based grain agriculture. And there's evidence that these systems degrade soil and water resources on millennial timescales. The Fertile Crescent, the region that gave rise to the world's first cities, is now largely desert. Not because the climate fundamentally changed, but because the land was farmed to exhaustion over thousands of years. Soil recovery, when it happens naturally, takes centuries. If you're continuously extracting without replenishing, you're on borrowed time. And for societies that developed large-scale agriculture around 400 to 300 BCE, that borrowed time started running out around 2000 BCE to 1000 CE, roughly the collapse window for many of these civilizations. The second theory is institutional. Political scientist Joseph Tainter argued that societies collapse when the cost of complexity exceeds the benefit. And there's a time frame baked into that process. In the early stages of a civilization, each increase in complexity, building roads, creating armies, developing trade, produces significant returns. It makes life safer, wealthier, more predictable. But eventually, you hit diminishing returns. The next road costs more than the first. The next layer of bureaucracy creates more friction than efficiency. The marginal benefit of each additional unit of complexity begins to decline. And at a certain point, typically after millennia of compounding complexity, you reach negative returns. You're spending more to maintain the system than the system is producing in value, at which point, simplification becomes rational. Collapse, in this model, isn't failure. It's a correction. A reset to a level of complexity that the available resources can actually sustain. The third factor is climate variability. Paleoclimate data shows that Earth's climate operates in cycles, not perfectly regular, but with identifiable patterns. The Holocene, the geological epoch we're currently in, has been unusually stable compared to previous periods. But even within that stability, there are century-scale fluctuations. Droughts that last decades, cooling periods that shorten growing seasons, shifts in monsoon patterns that alter rainfall distribution. Civilizations can adapt to gradual change, but they struggle with rapid shifts, especially when those shifts occur at a moment when they've already stretched their resource base thin. The Bronze Age collapsed around 1200 BCE, when nearly every major civilization in the Eastern Mediterranean failed simultaneously, appears to have been triggered, at least in part, by a prolonged drought at a time when those societies were already politically and economically fragile. The Maya collapse in the 9th century CE followed a similar pattern. It's not that climate alone causes collapse. It's that climate stress exposes the brittleness that complexity creates. Which brings us, inevitably, to the present. And to the question that makes all of this more than an academic exercise. Modern industrial civilization is roughly 250 years old if you date it from the Industrial Revolution. It is the most complex society that has ever existed. More people, more infrastructure, more interdependence, more layers of specialization. And it is built, fundamentally, on the same logic that governed every civilization that came before it. Extract resources, convert them into surplus, use that surplus to build and maintain complexity. The difference is scale and speed. We are depleting resources, fossil fuels, aquifers, topsoil, fisheries, forests, not over millennia, but over centuries. In some cases, decades. We have built a globalized trade system so interconnected that disruption in one node can cascade across the entire network. A semiconductor shortage in Taiwan affects car production in Detroit. A drought in the Midwest affects grain prices in Egypt. This is extraordinary efficiency, but it is also extraordinary fragility. Now, there's a compelling argument that we are different, that our technological sophistication, our ability to innovate, to adapt, to substitute depleted resources with alternatives, fundamentally changes the equation. And that argument has real merit. We have tools previous civilizations didn't. Renewable energy, genetic engineering, global coordination mechanisms, the ability to model and predict resource depletion before it becomes catastrophic. But here's the uncomfortable reality. Every civilization believed it was different. Rome believed its legal and military institutions were too sophisticated to fail. The Maya believed their astronomical knowledge and divine kingship made them uniquely stable. Ming China believed its bureaucratic meritocracy and Confucian philosophy insulated it from the chaos that consumed lesser states.